Unit 6, Day 4, More Identities by Courtney Bell and Amy Vera. The purpose of doing these identities is to make left side equal right side. Before we hop right into things, let's touch up on some things from the previous lesson. We know that the quotient identity is tan n theta equals sine n theta over cosine theta. Remember that n can be any number, not just 2. So we know that having tan n theta is the same as sine n theta over cosine theta. We can only work on one side at a time, so we separate left side and right side when making them equal to each other. So our left side equals tan n theta, and we can write these in our y, x, r terms. So we know that our tan is y over x, so that is our left side. And we know that our left side, our right side, equals sine n theta over cos n theta. And again, we can write these in our x, y, r terms. And we know that our sine is y over r. All over our cos in our xy terms is x over r. And to get rid of the denominator, we know that we have to multiply by the reciprocal. So we have y over r times our r over x now. And since our x's are two r's, are on our numerators and denominators, we can cancel those out. And we are left with y over x. Therefore, our left side equals our right side because they both equal y over x.
So we know that the Pythagorean identity is sine squared theta plus cos squared theta equals 1. So if we have our left side equaling sine squared theta plus cos squared theta, we're going to put that into our x, y, and r terms. So our sine equals y over r squared, and remember that squared is also on the denominator, plus cos in x, y, r terms is x over r squared, and the r is also squared. So since our denominators are the same, we just have to add our numerators. So that gives us y squared plus x squared all over r squared. And we know that from the Pythagorean theorem, y squared plus x squared equals r squared. So now we're left with r squared over r squared, which is equal to 1. And our right side was 1 from the beginning, so now we know that our left side is equal to our right side, because they both equal 1.
The other identities is the reciprocal identities, which is cosecant theta equals 1 over sine theta. And then we also have sec theta equals 1 over cos theta, and cot theta equals 1 over tan theta. And we don't need to prove these ones today because we already know these from our previous lesson. And here's just a quick summary of what we know so far. So we have this table of contents to make it easier to categorize all of our identities. At the bottom here, we also have just a couple quick little jot notes of how to go step by step through the identities, which would be a good thing to copy in your notes. They are: simplify the more complicated side first until it is the same as the other side. Apply the Pythagorean quotient and reciprocal when appropriate, using a common denominator or factoring as required, and common factor, factor, and use difference of squares to solve. So knowing these base identities, it will be easier for us to solve when doing harder identities.
So let's try a few examples. Let's say we have sec theta subtract sec theta sine squared theta equals cos theta. I see that my left side looks harder, so I'm going to start with that. So my left side equals sec theta subtract sec theta sine squared theta. So because of the reciprocal laws, I know that sec theta is equal to 1 over cos theta. So I'm going to change both of my sec thetas to 1 over cos theta. And I know, because of the Pythagorean laws, that sine squared theta is equal to 1 subtract cos squared theta. And I'm putting it over 1 so that I can multiply it in easier. So now we're going to simplify this by multiplying these terms right there. So I'm going to keep my 1 over cos theta at the start. And then I'm going to subtract my new terms. So I know that 1 times 1 is 1. And 1 times cos squared theta equals cos squared theta. All over my cos times 1, which equals cos theta. So now I'm going to subtract my numerator. So 1 subtract 1 cos squared theta equals cos squared theta. And you keep your denominator the same. So that is cos theta. So now we divide those terms, leaving us with just cos theta. And that is our left side. And our right side was cos theta all along. So therefore, our left side is equal to our right side.
And another example today, we have sec theta times 1 minus sine theta equals cos theta all over 1 plus sine theta. I'm going to start with my left side, and that is equal to sec theta times 1 minus sine theta. I know from the reciprocal law that my sec theta is 1 over cos theta, and that my 1 sine theta is going to stay the same, but I'm going to put that over 1 as well. And we're just going to quickly simplify that, and that equals our left side is our 1 times our 1 minus sine theta, so that's going to stay as 1 sine theta. And that's going to be all over cos, because we're going to do that, cos theta. And for our right side, we have cos theta all over 1 plus sine theta. And I'm going to multiply 1 minus sine theta in. Eventually, the 1 minus sine squared theta will make it to the numerator, and we'll see that further in the video. So I'll just show you here. So we have our cos theta times 1 minus sine theta all over 1 plus sine theta times 1 minus sine theta. And we can add in this multiplying, the 1 minus sine theta, because it's not changing any of the identities because we're doing it to both the top and the bottom. So our next step, we're going to just simplify, so multiply the numerators and multiply the denominators. So we have cos theta 1 minus sine theta all over 1 minus sine squared theta. And from the Pythagorean law, we know that our 1 over sine squared theta is equal to cos squared theta. So we're left with cos theta times 1 minus sine theta all over cos squared theta. And my cos theta can be canceled out by my cos squared theta right here. So cos theta. So we are left with 1 minus sine theta all over cos theta, because the 1 cos squared theta here cancels out this one. So we're left with just 1 cos left, which goes down here. Therefore, our left side equals 1 minus sine theta over cos theta. And our right side equals 1 minus sine theta over cos theta, which makes them equal.
So in conclusion, we want to make sure that we're working on our harder side first and making our left side equal to our right side. And make sure that you're always proving the law that you used, whether it be the reciprocal law, the Pythagorean law,
So you can't even check if someone was here this morning or something?
or quotient law.
So here's an example you can try at home and bring into class tomorrow. Just kidding. Thanks for watching. Bye.